This is tutorial 18 in a playlist that I'm preparing for Dynamics scenario creation with the 3D Experience platform. The actual application that we're using is uh, Mechanical Systems Experience, but I have two sub playlists for this. One is involving kinematic scenario creation, and the other one that this particular tutorial belongs to is the dynamic scenario creation. I want to explain how the velocity motor excitation is used in a very simple setup. Okay, uh, so we have to be in dynamic scenario. The problem that I'm going to be showing you in using this velocity motor excitation is shown here. Very simple prismatic joint. The ball, the block moving on a track as a in a linear way, translating way, and there is something out there that's it's a revolute joint and it's rotating. Okay. Now, uh, keep in mind that here I want to create two motors. One which describes this the motion of the block at a constant velocity, and the other one is the one that describes the rotation of that cylinder back there, that revolute joint back there, uh, as shown here. Okay. Now, the thing is that because this is done in dynamic scenario, you must assign the weights and or mass of the parts involved. Okay, that's the way it is. You cannot use these motor excitations in icons in kinematic scenarios. Okay, so here's the option that you have in using velocity. One is velocity law excitation. I've done tutorials on this thing. Maybe it was tutorial 2 or 3 in this playlist. And then right now I'm doing velocity excitation. Now keep in mind that when you click on the velocity excitation icon, the dialog box on the top appears. It says, okay, where is that thing that you're applying? You want to apply a motor to. So if you select, for example, the prismatic joint, you get the dialog box like this, which you can specify the speed or the velocity, and that's pretty much it. Okay. If you select a revolute joint, then it again gives you something that's very similar, but look at the units. This is radians per second or degrees per second, whatever your default units are. So they look the same, but one of them is controlling the revolute joint, the other one is controlling the prismatic one. And here's the documentation in the 3D experience, which is fairly brief. And that's really the purpose of doing these particular videos. Okay. Uh, Incidentally, tutorial 19 is also going to be related to this business, but we'll worry about it later on. Okay. Let me start with assembly file and insert in it a 3D part. That's going to be my track, 3D part. This is going to be the track. Just wait for it to pop up. Okay. So I'm going to call this thing the track. Right click, properties, track, which is incidentally stationary, obviously, and therefore the mass of it, although it has to be specified, is totally irrelevant. Let's double click on it. Okay. So I'm in part design. On that vertical plane, I will sketch. I'll sketch a 10 millimeter by 10 millimeter block. So let's see now, dimension this thing. Oh, I'm sorry, this is a track, right? Yeah. So let me make it, uh, what is this? Put down 10 millimeter, fine. And this height, I'm going to make it 5 millimeter. No particular reason. There we are. And exit. And I'm going to pad this thing by 100 millimeters. So we go to Essential, Pad, Symmetrically, 100 to the left, 100 to the right. Okay, good. So this is my, ooh, that's too long. Sorry, let me go ahead back here. Oh, this is a meter. That's not what I meant. 100 millimeter. That's a lot better. Okay, so now I'm going to insert the block. Right click, insert 3D part. I'm going to call this thing the block. And block. Okay, let's go make it. So on that same vertical plane, I will sketch. Yeah, let me make another centered rectangle just for the sake of simplicity. So this is 10 millimeters. And this is also 10 millimeters. Exit. And then pad it. I'll make it a block. So let's make it 10 millimeters. There. Now, this other one is going to be the cylinder back there. I can mount that thing on this block, but to make sure that things look easier when I look at it, I'll mount it at the very end. So there is a cylinder out here that's rotating. Okay, so let me go all the way to the top. Insert 3D part, and I'll call it cylinder or rotating mass. Properties. I'll call it rotating mass. Rotating mass. Copy paste. Okay, let's go make it. Double click, go into part design. On that plane, I will sketch. Cylinder. I'll, I'll just make it coincident in a minute. The radius of it doesn't matter. So at this point, I want it to be coincident with that point because I want to use the edge of that track as the axis of rotation. Okay, so let's make it coincident or dimension between them equal to 0. Either way, it's entirely up to you. Exit, and then pad it in the other direction, of course, by, I don't know, maybe 20 millimeters. Okay, so there's my cylinder. Okay, that's pretty much it. Now, let's create our joints. So this is going to be a revolute here. First of all, we're going to fix the track. The track is fixed. Very good. Fix the track. Now it's fixed. Create a prismatic between uh, I'll use the very last this one this template entry So that edge and this plane and that plane. And for controlling things, now remember, when you create a motor, when you create these velocity motors, you must have a command developed so that you can pick it. Okay? It's very important. You need to have a command for this prismatic joint and a command for that revolute joint in order to be able to pick it where the motor is going to be. Okay, so here for the offset, I'm going to measure the distance from this end to that end. That's entirely up to me, right? So right now there is, yeah, that's what it is. Very good. I don't want to do any contact calculation. Very good. Now let's do the revolute one. So here's the revolute. I'll do the fourth one. I like this fourth one because I'm used to it. This edge and that edge, this top plane and this plane. And for the angle to control, because we want to put a motor later, you have to specify which planes. Any vertical plane, I can use any vertical plane of this and the vertical plane of the track. So let me select, for example, for the rotating mass, use YZ, and for the tracks, use YZ. Obviously, that angle is going to be 0, but we're going to control it that way. See that? 90 degrees. Okay, what do I use here? Yeah, YZ 90 degrees. That's fine. No problem. Okay, so we go all the way to the top. We're pretty much done here. Actually, you know what I'm going to do? I'm going to create a point in the cylinder because later on I'm going to set a probe there. So let me go ahead and let me go back to rotating mass and create a point, say at the center of this top circle. Later on, I'm going to do something. Well, actually, I didn't want it there, so let me make it another. At this point, I didn't want it at that. Do another one on a curve. How about that? On a curve. That first one was useless, so I don't need it, and it doesn't matter where. Okay, this point is going to be good for me. I don't want that one. But I'll just leave it as. If it's bothering you, you can go and delete it. As a matter of fact, let me go ahead and do that. So let me go here. The first one I'm going to delete. Perfect. All the way to the top. Now we have to go and create our mechanism. So we go to mechanical systems, design. That's where you create your mechanism and specify masses and things like that. Okay, good. First of all, here's how you specify the weight, mass. Okay, everything is unknown right now. So I select the track and I go to the hyperlink and I say assign, click this checkbox, and it assigns properties of steel to it. So close it. Notice that one of them is now okay. Then I go and select the block, again hyperlink, click that checkbox. This is going to be made out of steel. Close it. And the cylinder, hyperlink, make it out of steel and close it. Without defining these properties, you cannot use a dynamic scenario and therefore you cannot put a motor there. Okay. Now, let's create our mechanism. See that mechanism representation. Say okay. Uh, yeah, so let's see what we've got here. We've got, not this, we've got a fixed part, a prismatic one, and a revolute one, and they're all driven. Like this one is length driven, this one is angle driven, so that's good. Okay, we now go, to mechanical systems experience. There's the mechanical system design that we just read there, and now mechanical systems experience to create a simulation. Okay, good. Notice that the joints have been created, the prismatic one, the revolute one. There are two commands here. One is prismatic command, the one of them is revolute. And then we go and create our motor. So velocity, motor excitation, you click on it, that thing pops up, and what you see there is exactly what I showed you in the slide, right like there. Okay, so let's go ahead and pick our first command, for example, the prismatic one. This is the prismatic one, see that? This thing pops up and says, how fast do you want this thing to go? So let me make it maybe 10 millimeters per second. How about that? 10 millimeters per second. Okay, I can type it in. 10 mm underscore s, which converts it to meter per second because that's what my standard units are. And then we say OK. Notice that it did create a motor excitation here. If you go further down, well, we'll see that. Okay, right here. And do another one. This time we select the revolute command. How about make it, I don't know, maybe 180 degrees per second? 180 DEG per second, or you can put RPM, turn per minute, you can put radians per second, it doesn't matter. You say, okay, good. And now that we do it, let's go and do a probe here, by the way. A probe, I'll make two probes here. Probe, one is at that, well, how one of them is this corner point. Another one, another probe for that point on the periphery that I created. Okay, very good. Let us now go and create our dynamic scenario creation. Here are the two motor excitation. We have to send them to the right side. Here are the two probes. Send them to the right side. Okay, and let's do a simulation. Not 10 seconds. I'll make it, how about 9 seconds? 9 seconds. It doesn't matter. And which integrator you use, it doesn't matter in this problem. Okay, that's pretty much it. So let's go ahead and run it. So we go to scenario and force it. Force uh, compute and create results. So basically, I've specified the linear speed of the block and the angular speed of that cylinder back there. Okay, that's good. So instead of me going to a formula and write that the velocity is equal to whatever I want times time, and the angular velocity equal to whatever I want times time, these motors allow you to specify those very simply. Now, let's go ahead and check our probes to make sure that in fact it is what we got. So we go here. Let's give it a second. Okay, deselect everything. Let me select the, uh, remember there are two probes here, here. Let me see now. Let me let me look at velocity. First one, I'm not sure which one was which, but x linear velocity. That's the one that, yeah, it should be 10 millimeters per second, right? 0.01 meter per second. And this other one, the angular velocity, that's the one that I got, I typed in 108 degrees per second, right? Okay, so let's check it. I can see here the linear velocity is right there. You can see that linear velocity. Linear velocity is 0.01 meter per second, which is 10 millimeters per second. Okay. Now the angular velocity is something, oh, this is radians per second, okay? You can convert things, but the moral of the story is that it will be that constant. It is, you can already see that is the constant value for the linear velocity, and it should be the constant value for the angular velocity. Let me check, make sure that I selected the right stuff here. Angular velocity. So let me see for a second. Is there another way? Angular velocity. Oh, for probe two, because that first the probe does not even have an angular velocity, but the second probe does. Right there. Now there should be another graph. Oh, wait a minute. Let me see for a second. Where are my commands here? Linear velocity. There's another way we can do this. Let me uncheck that. Let me select the linear velocity and the angular velocity, these two. Yeah. One of them is, if you go to the table, you see that one of them is that 180 degrees per second, okay? And this unit is, of course, radians per second. Yeah, that's pi is 108 pi radians per second. So there is your 3.14 angular velocity, and here is your linear velocity, which was constant. As I said, look, it was kind of confusing. Those not I didn't use those probes. One of them was useless to get the angular velocity. But look at these are my commands here. These are my commands. Okay, linear velocity came out to be 10. This is angular velocity right there, and it's not associated with any of these two probes that I created because those are listed here. You see that? 2, 2, 2, 2, 2, 2, 1, 1, 1, 1, 1. And these are not related to the probes, but the commands that I gave. That's pretty much it, guys. Tutorial 19 is also related to this business, but in a different context. Good luck.